What truly sets a Formula One car apart from anything else on wheels? These are not mere vehicles, they're precision-built marvels that defy the limits of physics. From cutting-edge aerodynamics and suspension systems to hybrid engines and that iconic steering wheel, every detail serves a purpose. Join us as we uncover what makes these machines the most advanced on Earth and find out the real reason behind their brilliance: the steering wheel, a driver's command center. In Formula One, the steering wheel isn't just a tool. It's the nerve center of the entire machine. Compact, rectangular, and loaded with technology. It gives drivers total control within a space barely larger than a tablet. Unlike regular cars that require wide turns, Formula One steering wheels only need slight movements, often less than 180 degrees, to change direction thanks to their ultra-precise power steering and sensitive suspension systems. But steering is only part of its purpose. Each wheel is packed with over 20 buttons, dials, and paddles controlling vital systems. From brake balance and differential settings to engine power modes, drivers use radio buttons to communicate with engineers and activate the drag reduction system for overtaking. There's even a hydration button linked to a tube in the helmet, ensuring drivers stay focused and hydrated through 305 kilometers of high-speed intensity. The aerodynamics in Formula One. In Formula One, every curve, contour, and flick of carbon fiber serves one purpose: to tame the air. Aerodynamics isn't just important. It's the heartbeat of a modern F1 car's performance. The entire body is sculpted to control airflow, maximizing downforce, the invisible force that pushes the car down onto the track for better traction and control. Engineers manipulate high-pressure zones above the car and low-pressure zones beneath it to achieve this delicate balance. At the front, the wing acts like an air conductor, slicing through the wind and curving it upward to create a pressure difference. This generates massive downforce, enhancing grip through corners taken at speeds often exceeding 300 kilometers per hour. But too much turbulence can slow the car down. So intricate elements like barge boards, diffusers, and side pods are designed to smooth airflow and minimize drag. Perhaps the most fascinating innovation is ground effect, where the car's underbody acts like a vacuum, sucking it toward the asphalt. Reintroduced through the 2020's regulations, ground effect now plays a crucial role in reducing dirty air and improving stability during high-speed battles. Combined with wind tunnel testing and computational fluid dynamics simulations, F1 aerodynamics represents the perfect fusion of physics, art, and relentless human ingenuity. The secret to Formula One's perfect balance. When it comes to Formula One, every millimeter of movement matters, and that's where the suspension system becomes a masterpiece of engineering precision. Unlike standard road cars designed for comfort, F1 suspensions are built purely for control, speed, and stability. Their mission is to keep the tires glued to the asphalt, ensuring maximum grip through every twist and turn. At the heart of this setup are double wishbones, lightweight arms connecting the wheels to the chassis, allowing engineers to finely tune how the car reacts to different forces. These are paired with torsion bars, which act like coiled springs but twist instead of compressing to absorb shocks. Anti-roll bars counter body tilt during cornering, while anti-dive systems keep the car level under hard braking or rapid acceleration. Together, these components allow an F1 car to stay perfectly balanced and aerodynamic even beyond 300 kilometers per hour. The braking system. If you think the car's brakes are powerful, imagine stopping a machine traveling at over 370 kilometers per hour in just a few seconds. That's what a Formula One braking system does. A true masterpiece of engineering built for extreme performance. Each F1 car uses dual brake circuits, one for the front wheels and another for the rear. This design allows drivers to electronically adjust the brake balance mid-race, adapting instantly to the unique demands of every corner and straight. The brakes are made from carbon fiber reinforced carbon, capable of withstanding temperatures exceeding 1,000 degrees Celsius, that's 1,832 degrees Fahrenheit, without losing performance. But it doesn't stop there. The system also connects to the motor generator unit, kinetic, part of the hybrid energy recovery system, capturing heat energy during braking and converting it into electrical power. Meanwhile, ventilated carbon discs with hundreds of micro holes provide essential cooling, ensuring consistent braking even under the most brutal conditions of racing. The power unit. At the core of every Formula One car lies a marvel of engineering, the power unit, a hybrid masterpiece that defines speed, precision, and efficiency. Modern F1 machines use a 1.6-liter turbocharged V6 internal combustion engine paired with an advanced electric motor, creating a combined output of over 1,000 horsepower. The ICE alone produces around 750 horsepower and operates at blistering speeds exceeding 15,000 revolutions per minute, pushing the limits of thermal efficiency beyond 50%, a figure unmatched in most road cars. To feed this ferocious engine, cool air is drawn through intakes near the cockpit, compressed and forced into the combustion chambers for explosive power generation. The turbocharger and intercooler work together to maintain optimal performance, even under extreme track temperatures. The energy recovery system completes this technological symphony. With its motor generator unit kinetic harvesting energy from braking and motor generator unit heat capturing energy from exhaust gases, every lost watt is turned into electric power. This stored energy, when unleashed, provides an instant 160 horsepower boost, perfect for those breathtaking overtakes that define Formula One. Drag reduction system. It is a striking example of how engineering elevates performance. When activated on a Formula One car, a portion of the rear wing flattens, dramatically lowering aerodynamic drag and allowing the machine to reach higher straight-line velocity. This advantage shines especially during overtaking. The trailing car, when within 1 second of the vehicle ahead, can deploy DRS in designated zones and gain the edge. Introduced for the 2011 season to make races more exciting, DRS transformed driver strategy, blending pure speed with tactical positioning. It's a vivid reminder that technology in motorsport doesn't just support performance, it also intensifies the thrill. Fuel and efficiency. When it comes to raw speed and clever innovation, few systems in Formula One capture both better than the drag reduction system, or DRS. This ingenious feature allows a section of the rear wing to flatten when activated, cutting aerodynamic drag and letting the car surge forward at breathtaking speeds, sometimes gaining over 10 to 12 kilometers per hour on straights. Originally introduced to make races more thrilling, DRS has completely reshaped the overtaking strategy. It's not just a tool for faster laps. It's a piece of engineering brilliance that turns precision technology into pure racing drama. Formula One's race toward a sustainable future. For decades, Formula One has been the ultimate proving ground for innovation, driving advancements like hybrid power units and aerodynamic breakthroughs that eventually transform everyday cars. But as the world shifts towards sustainability, the sport faces a new challenge. Can it maintain its thrilling speed while protecting the planet? Hybrid technology has been a strong start, yet the next leap might be embracing fully electric engines. An all-electric Formula One championship might sound controversial to purists, but progress has always fueled this sport. Formula One isn't just about racing, it's about redefining engineering excellence in real time. From blistering speeds to breathtaking precision, Formula One engines truly represent the peak of human engineering. Every roar tells a story of innovation, power, and perfection. But with constant evolution, could we be witnessing the limit, or just the beginning of engine technology? Share your thoughts below, and don't forget to like, share, and subscribe for more.